Today's lesson is on multiplying and dividing decimals, and our standard is still to fluently add, subtract, multiply, and divide multi-digit decimals. And today we're going to look at not only the algorithm or the mathematical process to finding decimals, we're also going to look at a couple pictures to help us out. So you may want to have some colored pencils or markers or something with you while we're doing these problems. To start out, let's show a multiplication example. 53 hundredths times 2. Now what I have here are 2 hundreds grids, and this is going to help me show what portion of a whole one is 53 hundredths. So let's think that one big square is a whole. It's a value of 1. To take 53 pieces out of that 100 pieces that make up that whole would look something like this. Let's color in our whole half of our hundreds grid, right? Nice and thoroughly. And then 3 additional squares there. So first I have 53 hundredths, but I need 2 sets of 53 hundredths. So I need a whole nother set of 1, 2, 3. Well, I guess I have to finish by shading this hole. If I used 53 hundredths in my purple color, how many hundredths are left in the blue? About 47. So how many more do I need from my second hole to get to 53? That would be 48, 49, 50, 51, 52, 53. So 53 hundredths times 2 looks like 1 whole and 6 hundredths. Now, when I go to solve this problem mathematically, I wonder if there's a way that we can get the same answer. Well, there absolutely is if we use the algorithm. So first of all, let's multiply our numbers, just ignoring the decimals. Ignoring the decimals. How is this going to work? So 53 times 2. I have a 0, and here's my decimal point, right? Multiply the numbers. 2 times 3 is 6, 2 times 5 is 10, carry the 1, 2 times 0 is 0, plus 1 is 1. All right, that was easy enough. Now I want to figure out how many digits do I have to the right of each of my decimal places, or each of my factors. So how many decimal places do I have? Well, in this problem specifically, in the first factor, I have 1, 2 decimal places. And in the second factor, I don't have any because 2 is a whole number, so if there would be a decimal, it would be right here. So I don't really have to worry about it. So I have 0 decimal places. Because I have 2 and 0 combined, I have a total of 2 decimal places. So I need to insert 2 decimal places into my solution. That way, I have a final answer of 1 and 6 hundredths. You may want to write in, we added, or I guess we inserted. You didn't add anything. We inserted the same number of decimal places into our solution. Great. Let's look at one more multiplication example. 8 times 4 100ths. Again, we can go ahead and color in our whole square and say, okay, so if I need to multiply 4 100ths, that's 4 1/100ths times 8. Well, there's one set. Here's 2. Here's 3. Here's 4. 5. 6. 7. And 8. So 8 times 4/100ths would be, it looks like, 32/100ths. If I use my algorithm, I could check my answer. So 0.04 times 8. 8 times 4 is 32. 8 times 0 is 0 plus 3 is 3. I have 2 decimal places in my problem, so I put 2 into my solution, and I have a final answer of 32/100ths. Perfect. That's exactly what I wanted. Let's move on to decimal division. Decimal division is fairly straightforward. It just takes a little getting used to. So, the problem that I want to start with is 1.5 divided by 3. In order for me to represent 1.5 on these 100 grids, I need to shade in one whole 100 grid, and then 1/2 of a 100 grid, because that would be 5/10ths. Now I need to equally divide my hundreds grids into 3 pieces. I'm going to do that vertically by making sure that I can see, but I know, whoops, I know that 5/10ths is equal to 1/2 of a whole, and I have 3 sets of 5/10ths in here. So 1.5 divided by 3 is 0.5, or 5/10ths. In order for me to do this out the long way with my algorithm, I need to divide 3 goes into 1.5. There's no decimal in my divisor, which is the 3. I have no decimal value there because 3 is always a whole number. That's key. I want my divisor to be a whole number. So your divisor should be whole. And if it's not, I will show you what to do. But at this point, my divisor is whole. So all I want to do is take the decimal point from my dividend and raise it up vertically and put it straight above itself. And that's where the decimal point is going to be in my solution. So 3 goes into 15 5 times. 5 times 3 is 15. I do my subtraction, and I know that my answer has to be 0.5 or 5/10ths. Now, what about that number that has a decimal in the divisor? Let's do one more example. Let's say 0.25 divided by 3.75. I have a decimal in my divisor, so what I want to do is shift it over the correct number of decimal places to make it a whole number. I'm going to repeat that process inside my dividend. So the number of places that I shift in my divisor, I need to shift an equal number of places in my dividend. Then I'm going to rewrite my problem. 25 goes into 375. And here's where my decimal landed. Same rule as before, wherever that decimal is in the dividend, I want to raise it straight up and put it in my solution. Now I can divide. 25 goes into 37 once, and I multiply, subtract, and what I have left is 12. Bring down my 5. 25 goes into 125 5 times. 5 times 25 is 125. Subtract. I have 0, and I'm all set. What that tells me is that 25 hundredths goes into 3 and 75 hundredths 15 times. That's my final answer. Here's a copy of my notes and the way that I finished up my problem. I scripted in a few more instructions with regard to the division process, but I don't think that's information that you really need. So please just make sure you have the notes from the previous page that I just recorded for you. Your proof has 2 problems, 1 multiplication and 1 division, and make sure you're solving those carefully and fluently in order to be successful.